So we will first take a look at what are the components we are using. We have an input source which mimics the solar power. Since we cannot use solar panel every time to show the experiment, we are using this input source which is having 6 volt and half amps, which is like the maximum efficiency which we can get from the solar panel. Then we have an external power supply. This power supply is used to power our displays, the relay switch and the controller. We are using a PWM controller, and the relay switch is a mechanical relay switch which has 7 relays. The first 6 is for parallel and series, and the 7th one is for source load switching. We are using a 3.7 volt lithium ion battery, 4 of them. So when we are using the MC board, all of these will be coupled inside. To make it easy for us to understand this entire technology, we have parted this entire board like this, and we have a CRO. The cathode ray oscillator is going to show us the duty cycle when we change from parallel to series and during the source load switching. And to show the output and to know how the voltage and the current are changing, we have the output monitor here, and the entire circuit is going to power a 5 watt bulb. We have a two-way switch. So this is an output source which can be used to see the reading. Anyway, these two are going to be the same. So now we will start with, in the controller we have 50 Hertz with 100%, which is 100% parallel and no series is happening, no series connection. So we can see parallel favors charging, so only input is we are getting only the input, and there is no output since it is 100% parallel, and the duty cycle is a pure DC wave. And when we turn on the switch, we don't give any power to the load. Since there is no power to the load, it is not turned on, it is not lighted. Now we will try reducing to 80% parallel and 20% series. So we hear all these sounds since we are using a mechanical relay. On the original MC board this might not happen. So it is 80% parallel and 20% series. We can see a voltage and current. At the same time, in the output also we see voltage and current. And the duty cycle, the one on the bottom shows the series and the top part shows the parallel. And since very little current is getting out, only 20% is on the series connection, the light bulb is ignited in very little brightness. Now let's try changing into 50% parallel and 50% series. We can see on the duty cycle both parallel and series have equal length. And the brightness of the bulb is also increasing. Now I will further try changing it into series connection. Let's see how the brightness increases. It is 40% parallel, 20% parallel, and now it is completely series connection. The light bulb is on full brightness now. We have 6 volt and no current on the input side, and the maximum voltage of 14.5, and we can see the current on the output which is discharging. So we are able to power the load with maximum voltage. And we see a pure DC on the series part. We saw how the brightness of the bulb is going to change, how we can switch from parallel to series by changing the duty cycle. Now let's try changing the frequency. All this time it was on 50 Hertz. So I will try making the duty cycle as 50% parallel and 50% series. Now we will try changing the frequency. So now the frequency is 50 Hertz. It's like 1 second it is going to flicker between parallel and series like 50 times. Let me try taking the frequency as like 20 hertz. We can see the flickering. So in 1 second, it's like going parallel and series like 20 times. I'll try going even further on, even lower on the frequency part. So now it is like only 2 hertz. So for every second, we can see it turning on and off for 2 times. We can also see the same changes on the duty cycle here. For every second, we can see the parallel and the series switching up and down.
I'm going to talk today about switching battery. So what this is it's a system that takes batteries and reconfigures them in series or parallel to change the voltage and currents that, depending on what the input and output are doing. We have 4 batteries. So in this specific design for this evaluation board, there is it's configured in there's 2 battery groups. Group A is what we call Group B. Each group can be configured in series or parallel. When you first power on the board, it'll default to so we have five states automatically just programmed into it. There is a lot of different states, a significant amount that you can go through and program if you'd like. We just picked 5 to demonstrate this. It'll pretty much be able to utilize a full one of these 280 watts panels. It'll be able to utilize the full wattage of one of these panels, and it will be able to handle the open load voltage or open circuit voltage of these 3 panels.